Welcome to this tutorial on Simulink best practices for large and complex models. In this session, we'll focus on project management and team collaboration in Simulink. Simulink projects help organize models, files, and settings in one place. It manages dependencies, handle paths automatically, and support version control, making teamwork and collaboration much easier. Simulink projects create convenient shortcuts to your models, data, and scripts right within the project folder. These shortcuts help you quickly access important files without cluttering your workspace, making navigation faster and more efficient. The Share feature in Simulink projects streamlines collaboration by packaging your project files, dependencies, and settings into a single shareable archive. This makes it easy to send your entire project to colleagues, ensuring they have everything needed to open and run the models exactly as intended. The Tools section in Simulink projects offers powerful utilities like the Dependency Analyzer, Package Toolbox, and Process Advisor. These tools help you identify and manage model dependencies, create and share custom toolboxes, and analyze your project workflows to optimize development and collaboration. The settings in Simulink projects allow you to customize and control project-specific configurations such as path management, startup and shutdown tasks, and automating tasks. Adjusting these settings helps tailor the project environment to your workflow and ensures consistent behavior across team members. Labels in Simulink projects help you organize and categorize your files and folders by assigning custom tags. This makes it easier to filter, search, and manage project contents, especially in large projects, improving navigation and boosting productivity. In Simulink projects, files and folders help you organize all your models, scripts, data, and related resources in a structured way within the project environment. A well-organized folder structure is key to managing Simulink projects efficiently. Here's a recommended layout. Doc folder stores design documentation, providing clear reference materials and specifications. Requirement folder contains model specifications and requirements to guide development. Model folder holds model templates, libraries, and reusable components. Data folder includes parameters, input data, and bus definitions for consistent data management. Model settings folder contains model configuration sets to maintain consistent simulation and code generation settings. Configured model folder used for the model under test, containing checked out models, associated data, and configuration sets. Test folder defines test cases and stores test results for validation and verification purposes. Work folder stores generated artifacts such as Simulink cache files and automatically generated code, keeping the workspace clean. This structure promotes clarity, modularity, and easier collaboration, making it simpler to navigate and maintain your projects. Simulink project references allow you to link multiple Simulink projects together, enabling modular development and reuse of models and resources across projects. This approach supports modular and scalable development, allowing teams to share models, libraries, data, and configuration settings without duplicating files. By using project references, you can maintain consistency across projects, streamline updates, and simplify collaboration, especially in large or multi-team environments. This also helps in managing dependencies efficiently and keeps your projects organized by clearly defining relationships between them. Imagine you have a top project that represents the overall system, such as a vehicle control system. This top-level project references two domain-specific projects: the engine project and the steering project, each responsible for modeling and simulating their respective subsystems. To promote reuse and consistency, these three projects, the top project, engine project, and steering project, all reference a common shared project that contains libraries, data definitions, and utilities used across domains. Let's talk about how source control works with Simulink projects. Simulink projects integrate seamlessly with source control systems like Git and Subversion. This allows you to track changes, manage versions, and collaborate with others more effectively. The project interface makes it easy to view file status, commit changes, resolve conflicts, and work with branches. We start by editing files in your working directory. When you're ready, you commit those changes to your local repository. This saves a snapshot of your progress. To share your work, you push from the local repository to a remote repository like GitHub. To get updates from others, you fetch from the remote repository to your local one. To apply those changes to your working directory, you either check out from the local repository or pull directly from the remote. Pulling combines fetch and update. Let's talk about a three-way merge in Simulink. Say we start with gain equals 1. In their branch, it changes to gain equals 2. In my branch, I change it to gain equals 3. When I try to push my change to the master branch, Git sees a conflict. Git then does a three-way comparison: the original version, their version, and mine. You can use the Simulink three-way merge tool to resolve the conflict. Once resolved, you complete the merge and push. Let's look at an example that shows how Simulink projects support source control and help you review, analyze, and merge changes effectively. First, we create a new branch called My Branch. Then, we pull the latest updates from the master branch to ensure we're up to date. Next, we open a model and make a change, for example, updating a gain value. After the modification, we go to the Source Control tab, where Simulink indicates that the model has been modified. By clicking Impacted, we can quickly see which files are affected by the change. We can also compare the modified model with its ancestor to review the differences. Once reviewed, we commit the change and push it to the remote repository under My Branch. When we attempt to merge My Branch into the master branch, Simulink identifies conflicts. By clicking View Conflicts, the three-way merge tool opens, clearly showing differences between the base version, their version, and our version. It also shows the status of each conflict, whether it's resolved or still unresolved. Some conflicts are resolved automatically, while others need manual input. Once all conflicts are resolved, we click Accept and Close. Now, when we push to the master branch, the merge completes successfully. Finally, opening the branch manager, we can see that My Branch has been successfully merged into the master branch. While the three-way merge tool is powerful for resolving conflicts, the best strategy is to avoid conflicts altogether. The easiest merge is no merge. One effective way to do this is to break your models and data into smaller, well-organized files. This reduces overlap between team members' work and minimizes the chances of conflicts during collaboration. Alright, I hope this session gave you some useful insights into setting up project and team collaboration workflows in Simulink. In the next session, we will explore the modeling guidelines. I look forward to your participation.